Hello, we are in the double angles and half angle formula discussion. So these are just more formulas to add to our already big collection of formulas that we already have in trigonometry. So let's begin with the theorem. All right, so double angle formulas. Sine of 2 theta is the 2 times the sine of theta times the cosine of theta. And cosine of 2 theta is cosine squared minus sine squared of theta. Now this actually has 3 different values. It could also be 1 minus 2 sine squared and 2 cosine squared of theta minus 1. Now in the double angles formulas, you might, well, where do they come from? It basically comes from the addition formulas. Sine of 2 theta is the same thing as sine of theta plus theta. So you can use the addition formula for the sine, and then it'll come out to be 2 sine of theta times cosine of theta. And similarly, cosine of 2 theta, you can break it up as the cosine of theta plus theta and use the addition formula for cosine. And then you'll get that first one, cosine squared of theta minus the sine squared of theta. But then if you change the cosine squared to 1 minus sine squared, and that second one coming down, if you change the cosine squared to 1 minus sine squared, it becomes 1 minus sine squared, which gives you the third one. But on the other hand, if you change the sine squared on that, the second one, and change it to 1 minus cosine squared of theta, then it becomes cosine squared of theta minus 1 plus cosine squared of theta, because you distribute, and it gives you the fourth one. But regardless, these are the formulas. You don't really need to know where they really come from, which is what I just described, but you do need to know the formulas to use them, okay? These are not formulas that you really need to memorize, but you need to know them what they are, and that they do exist. And so if you do need to go find them, you know where to go look. And so, all right, so let's begin with using these. So using the double angle formulas to find the exact values. So yeah, what we're doing is these double angle formulas, what we're going to be doing with them is finding more special angles. So we know cosine of theta is 2/5. Now, theta is between pi and 3 pi over 2. Now, that's a fancy way of saying theta is in the third quadrant. Find the exact value of sine of 2 theta. Now, we already know that the sine of 2 theta was what? It was 2 sine of theta times cosine of theta, right? All righty. But in order to do that one, we need to know what cosine of theta is. And we need to know what sine of theta is. Okay? So let's look at the problem again. So we have sine of 2 theta. We know it's 2 times the sine of theta times cosine of theta now. They give me cosine of theta to be negative 2/5. What do I need? Yep, I need the sine of theta. So that's the first thing I'm going to find, but I'm going to use the Pythagorean identity to help me out. Sine squared of theta plus cosine squared of theta equals 1. So therefore, sine of theta is equals to negative square root of 1 minus the cosine squared of theta. Now that negative is kind of ominous there. It's kind of looks like, well, what's that doing there? Well, if you take the cosine squared to the other side and take the square root of it, technically it's plus or minus, right? When you take the square root. But where's the plus? Well, the thing is, if it's plus or minus, that means I don't know what it is. But in this case, I do. Why do I know what the value is? It's going to be a negative in this case. How come? Because we're in the third quadrant. Theta is between pi and 3 pi over 2. Sine is negative in the third quadrant. So that's why they had to give me that. So I had to know which one that was going to be, plus or minus. So it's going to be a negative square root of 1 minus cosine squared of theta. So now that I know cosine of theta is negative 2/5, I drop it in. So it's going to be negative 1 minus the negative 2/5 squared. And it ends up being negative root 21 over 5. So that's what sine of theta is. So if I want to figure out what the sine of 2 theta is, I use the formula 2 sine of theta times cosine of theta. I now know what sine of theta is. It's negative root 21 over 5. I know what the cosine of theta, it's negative 2/5 because that was given to me. And so doing the algebra, it's 4 square root 21 over 5. Now, notice sine of 2 theta is positive 4 root 21 over 25. And you're like, wait, I thought sine was negative in the third quadrant. It is negative in the third quadrant. But look at sine of 2 theta. It's positive 4 root 21 over 5. So what does that tell me? That tells me 2 theta is not in the third quadrant. And it's not. Theta is in the third quadrant, but 2 theta, since it's positive 4 root 21 over 5, that means 2 theta will either be in the first quadrant or the second quadrant. Right now, I just don't know which one. Okay? Now, cosine of 2 theta is equals to, remember the formula, one of the formulas is 1 minus the 2 sine squared of theta. Remember, it was three different things. You can make it equal to either one of them. It really doesn't matter which of those three you choose, because you know both the sine and the cosine. I just chose this one. So it's going to be 1 minus 2 sine of theta is negative root 21 over 5 squared. And that's going to be 1 minus 42 over 25, which is negative 17 over 25. So cosine of 2 theta is negative 17 over 25. So what quadrant is 2 theta in? Now, when I evaluated the sine of 2 theta, I thought it was positive. So I said it was either in the first or second quadrant. Cosine of 2 theta just told me which one it's going to be then, because it's a negative 17/25. So, excuse me. And so therefore it is in the second quadrant, because cosine is positive in the second quadrant, where cosine is negative in the second quadrant. So we're in the second quadrant. Alrighty. So that concludes this discussion. If you have any questions, you let me know, and you have a good day.